So first, a little bit about me. My name is Lenart. I have about 5 years of experience in software engineering. The majority of my time was spent on front end, more specifically Angular, but I do have some knowledge in full stack development with some personal projects in Laravel and Vue. I joined Triton a little over a year ago now, and I was expecting to follow in the same sort of field. So anything from Angular, Vue, something that I was used to, but I was surprised that my first possible assignment here, my first client, was actually a React Native project. So I wasn't sure how that's going to go, because it was my first time in a React environment altogether, and more specifically React Native, which is mobile development. It was even a bigger shock, but later I found out that it's not that big of a deal to transition over. It's really easy to get started. So what is React Native? It's based on React. It uses the same templating engine that is JSX. Of course, the difference in templating is we don't use HTML elements here, but we use a set of pre-built components that React Native provides for us, such as view, flat list, text, pressable, and so on. How it works behind the scenes is due to help of a so-called bridge that I'm going to be explaining a bit more later. A plus point for React Native is that compared to some of the other alternatives, such as Ionic, it uses actual native elements. It renders native elements instead of packing all of the views in a web view and then displaying it on the device. And it also exposes platform APIs such as gyroscope, camera, etc., that we can, with a little help from the native code, if we do know how to write it, we can implement that into our application. Most common examples of React Native in production include Facebook, Skype, Tesla, Pinterest, Microsoft Teams, and many, many more. So what is Expo then? We must not confuse it with another JavaScript framework in the sea of all JavaScript frameworks out there nowadays. It is rather a set of tools and services that are built on top or around React Native to help developers get an easier or more pleasant experience while developing mobile apps. It is incredibly easy to get started. As I mentioned, I was a bit scared at the beginning on how it's going to go, but even the React Native documentation suggests newcomers to use Expo to get started with mobile development. Expo has all of their builds and updates and any data in the cloud, so it's accessible everywhere and anytime. And they built an SDK on top of those platform APIs that I mentioned before. So Expo provides us with an SDK for a camera, for notifications, for a gyroscope, location, and so many more. It's really a huge SDK. And the benefit here is that we don't need to know any native code. Expo built that for us, so we don't need to touch any of Objective-C or Swift or Java or Kotlin. And the main feature of Expo is, of course, the Expo application services, which offers easy steps to build our app, to submit our app to the App Store, to push the over-the-air updates, and a couple more features. Of course, as I mentioned, push notifications. The good thing about these notifications is that while in development, we don't really need any Apple credentials or Google credentials, and we can still test it out pushing remote notifications to our devices without committing to a paid plan beforehand. So we only need to do that on production. While if we are building in a bare React Native flow, we need to buy the credentials if we want to test out the notifications even in development. Over-the-air updates, for example, this is really useful to push any of the small bug fixes or UI updates or typos or really small features. Essentially, it bundles, it makes a JavaScript bundle and it uploads it to Expo servers. And then anytime a user opens the app on their device, it checks if there's any new JavaScript updates, and then it injects that into their app. So we don't need to make a new build every time we push a small fix to the app. And then a camera and location are another two examples of how easy it is to implement that if we are using Expo. For example, here, if we used bare React Native, we would need to probably write some of the native code ourselves to access all of the native platform APIs. But Expo provides us with a simple hook that we can use to get the user location data. And same goes for camera. Use camera permissions. That's all we need to do to check for the camera permissions. And of course, if we want to then display the camera to the user, if the permission is granted, Expo also has its own component built in for this. So what are the main differences of the two workflows? They are called bare workflow for React Native, and then with Expo, it's a managed workflow. So first things first, React Native, we can use a lot of native models whenever we need. With Expo, it used to be that no native models were supported out of the box. But their introduction of custom development clients, we can write our own native models and include them in the custom dev client. So this pros and cons are getting, the line between them is getting blurred more and more with each passing month. Of course, the React Native has a smaller bundle size because they don't have the extensive Expo SDK included and all of the native code. And on the other hand, Expo a slightly larger bundle size. For developing in React Native, we need to have Xcode and Android Studio, or either one of them if we're just developing for one platform. And with Expo, we don't need any of this if we are just showing the preview in our development on our device. If we want to run it on a simulator, of course, we need to have these two installed. But for running a preview on our device, on our actual physical device, we just need to scan a simple QR code that gets generated, and we can access our app via a tunnel or a local host. So we don't even need a cable. Sharing in React Native to a friend, to a colleague to check out the app means sharing the actual build file. While in Expo, we can just share them the QR code or a URL that they can open, and they will be able to open up the app in development on their own device. Project setup, as I said, in minutes and really easy for Expo. In React Native, it's a bit more time consuming at first, but you get used to it at some point, and you can even make some shortcuts. Expo Go is the development client I mentioned. It comes pre-packed with support for all of the native modules that Expo support out of the box. This comes in the shape of an app that we just install on our physical devices, and then we can open our app in development inside that app. So it acts, as a development client. So as I mentioned, if we want to include any native code, we need to make a custom development client, and then we can go on about our business. And the Expo API, the SDK, is really huge, and it benefits developers that are just starting. It saves a ton of time, and you don't really need to know any of the specific languages for both platforms, just React. And there are any other alternatives to React Native? Of course, the most common one I'd say is Flutter, that uses Dart language. Then we have Cordova, that uses the standard HTML, CSS, and JS. Xamarin by Microsoft uses C#, and then Ionic, which I mentioned before, that renders web views. The good thing about Ionic is that we can use any of the famous front-end frameworks that we desire. So it can be either React, Vue, or Angular. But as I mentioned, it doesn't render actual native elements. So how does it compare to web? Just a brief showcase. A div would be a view component in React Native. A button would be a pressable or maybe a touchable opacity or touchable opacity without feedback. There's a couple options that we have for a button. An input would be a text input, and a p tag or any other tag that we want to wrap some text in needs to be wrapped in a text component. In React Native, we cannot just write text anywhere. It needs to be wrapped in a text component, otherwise we'll get an error while in development. So how does it work? I mentioned the bridge, and I like to think of this like having three people trying to communicate, but they all speak a different language, and only that language. So we have JSX, we have Swift, we have Kotlin. So how will they communicate with each other and know what's going on? So in a real-life scenario, if you have three people speaking three different languages trying to get to a common ground, you would, of course, put some kind of a translator in between that knows all three languages. So it's the same here. The bridge essentially acts as the translator, and it works by asynchronous communication between both between the native side and the JavaScript side. And JavaScript or React Native comes with a set of pre-built components that I've mentioned, and each of those components has some sort of predefined mappings and rules as to how they are gonna be represented on the native side. So each of these sides don't know anything about each other, but the bridge knows, and the bridge actually tells the native side, okay, I've run into a view. I see that view has this and this rules and maps into what this view should represent, how this view should be represented in the native side. And for example, let's say if we get a horizontal view, okay, in Swift, it's going to know that it should render an H stack, and same goes if it runs into a vertical view on Swift, it will know that it should render a V stack. And of course, styles and props are also mapped, and they have their rules at the beginning. So there's a couple of examples here that I mentioned. A simple view. Of course, I should mention that unlike in the web, in React Native, the default layout is flexbox and the default direction is column. So if we just render a default view, we'll get a V stack or a vertical stack in Swift UI. If we render a view with a flex direction of row, we're going to get a horizontal stack. And then the same goes for all the props and styles next. So text input, placeholder font, and keyboard type in numeric is going to know how to render that native element in UI. And the same goes for a simple text. We can change some font size, font weight, and it's going to know how to translate that into native elements. So the bridge has some disadvantages. So they're trying to make it better by introducing JavaScript interfaces. It's a new architecture that will allow JavaScript to communicate with the native side directly, so without any bridges in between. And that's due to the host objects. It's not supported by Expo SDK at the moment, and we will need to wait for a new version of Expo if they, of course, even support it in any future time. But the good thing about this is that it uses shared memory, so there's no more JSON serialization, because the bridge communicates with both sides via JSON, so it sends all the properties that it needs to one side and then back, and so forth and so forth. So we lose this JSON serialization and deserialization, which is very cost-effective in this case with JavaScript interfaces. So how does styling work, for example? In React Native, we have the inline style, the most common one, I mean, the most known in web as well. It, of course, uses JavaScript syntax and not CSS syntax, but all of these rules are, most of these rules are supported. Some of them are not. For example, a grid is not supported, and certain elements or pseudo elements like after, before, hover, and stuff like that is, of course, not supported in React Native. Then we have style sheets, which is the default way in how the first template that when you create a new app comes with. You have a style sheet where you can create all the objects that you will have in your JSX, and then you can apply the styles like it's shown in the picture. And of course, this style sheet object will also notify you in the IDE if one of the rules you're trying to make is not supported in React Native. Then you have the styled components that have become very popular on the web nowadays. Here you can actually write CSS syntax and then just use it normally how you would on the web as well. And if there's any Tailwind fans out there, there's possibility to use Tailwind in React Native as well, due to the native Wind NPM package that a really nice person wrote. This package also injects a class name property into our JSX, because class name by default is not supported in React Native. We can only use the style prop. So this kind of looks like something we would write on the web. But Native Wind also exposes their own styled API. So we can have styled components with Tailwind CSS classes and use them as shown in the picture. So as I mentioned, a simple command just gets us started with Expo. That is npx create Expo app, and then we choose a template. We can go for blank JavaScript, blank TypeScript, and TypeScript with some navigation already built in for us, so we can get started pretty quickly. I'm just going to show a quick example that I've prepared for the Ljubljana Tech call as well. Hopefully you can see the code and the phone. Yeah, so for example, let's first jump into how navigation works. So this is the home screen, and let me just see. This is the home screen, and here I have I can define a bottom tab navigator. And inside the navigator, I can define the screens. So this screen can be either a single component, or it can be another navigator nested inside as a screen. So we can, of course, like have multiple nested navigators, either drawer navigators or stack navigators or tab bar navigators. So this is the home tabs. We can tab between these and go to upcoming events and past events. And then we have the drawer navigator, which is this one on the top left, that we can open up and have all of our screens defined in here. So we can move to them, go to the location, and so on and so on. And then here we have a profile section, which then uses another tab navigator that I mentioned that is nested inside the previous one. And we can, of course, have, this is a text input example. Yeah, and if I go, for example, to the details page, I can see all the details about the event listed here. So Expo works with hot jewelry loading. So let's check the upcoming event detail screen. So here we have all the components. I've used some of inline styling, some of tailwind styling, and some style components just to get a mix of everything. For example, this seats is a simple style component. And let's check the badge, for example. The badge is the technology badge we see on the screen. So Expo works really nicely with this. Let's say we want to enlarge some of the padding on each side, and we press save, and it's going to expand just like that, and we see it immediately. So just like on the web that we are used to, we can see changes immediately here without having to reload anything. Okay, so that was a quick demo of this. And just a couple of pictures that I took from this. And so what are the next steps when we are ready with our application and we want to submit it to the App Store? So first we need an Apple developer account. Then, of course, if we want to submit it to Google Play as well, we need to enroll into Google's developer program. And then we just need to use the Expo CLI. So we need to log in to Expo CLI, and then we just say that we want to submit this app to the App Store, and it's going to guide you through the whole process of adding all the credentials that we need, adding all the information, and adding all the details that we need for a successful submission to the store. And it's going to save those credentials for any further submits that we might do, and it's going to sign the app with our credentials every time automatically. So when we are ready, we just say, okay, let's build this with this command, and we can choose different profiles. Of course, we can build for preview that, for example, some of the internal people or your colleagues or a client can see first before it goes out there, or we can build for production. It's going to submit to the App Store. And then we can submit it to either both platforms or one of those if we choose a -P flag. Or we can do that automatically with just adding auto submit at the end of the build, and it's going to build and it's going to submit automatically, and we can stop caring about or waiting when the build's going to finish. And then the Expo updates that I mentioned, how they work is we have to choose a branch. So it's either a preview build or a production build, and then a simple message. And it's going to take all of the code that we currently have. It's going to package it up in a nice JS bundle. It's going to send it to Expo servers. And then when the user opens the app, it's going to download that update and apply it immediately. So we can have bug fixes shipped in a matter of minutes. Cool. So I'm going to do the last update here and ask if there are any questions from the audience. Otherwise, thank you for your time, and I hope you learned something new today.
Thank you, Lenart. I think we all learned something new. I definitely did. So if there are any questions from here, speak now or forever hold your peace. Otherwise, I have a couple of questions here that I've received. I can go with those.
Yeah.
Okay, cool. Since you mentioned Expo updates, how is this being handled if, for example, someone changes a lot of things with one update, so possibly even the whole meaning or purpose of the app?
Yeah, that was interesting to me at first as well, but I'm sure that either Apple or Google have some sort of precautions or mechanics in place to notice too big of a difference. So Expo updates is not intended to make huge feature releases anyway, but you could potentially change the whole meaning of the app. Let's say you have a calculator app and change it to a crypto app. I'm sure that Apple and Google would flag that down really quickly. So I wouldn't go that way. I would just use it for small fixes and small updates.
Apple and Google flagging things down, Lenart. Next question is, how important do you think it is to understand the fundamentals of React before diving into React Native?
I don't think it's that important. As I mentioned, I haven't worked with React before diving into this React Native experience. So I had no knowledge of any of the React fundamentals, hooks, contexts, state management in React and stuff like that. And you just got to do it one time. So as you would learn React on the web, you can learn React with React Native. It uses the same fundamentals, the same principles. For the most part, the whole architecture in a project is pretty much the same. So I wouldn't say you need to have any React knowledge beforehand. It's better if you do, of course, but yeah.
Fantastic. Well, we've now hit 12:30, so I think I will cut it there. Thank everyone for coming. Thank you very much to you, Lenart, and also I wish you all a fantastic day. Thank you very much for joining us.